Good day, everyone. You're welcome to TFT 412 Milk and Dairy Technology. I am Dr. Olufunke Ezekiel, and I'll be your main course facilitator for TFT 412 Milk and Dairy Technology class. Introduction. It gives me great pleasure to welcome you once again to this class and to this course, Milk and Dairy Technology. And I'm happy to welcome you as eager students who are ready to learn the basic principles of those delicious milk products you come across almost on a daily basis. The knowledge and skill you will gain in this course will afford you the opportunity to learn how milk is produced as well as the manufacture of various milk products such as cheese, yogurt, butter, ice cream, and so on and so forth. In this course, you will also learn the process variables and various unit operations that are involved in milk processing right from inception to final products. The course will prepare you to work either as the production or quality control personnel in milk processing industry, and you will be exposed to both virtual and practical hands-on experience as it relates to milk processing and packaging as well. Milk and Dairy Technology course teaches the fundamentals of milk, milk properties, milk components, milk handling from reception to final product, milk transportation, milk storage, milk quality parameters, grading, and testing. So in this course, the various principles and mechanisms of manufacturing those products made from milk will be described, as well as the associated unit operations, the processing units, sanitation, and management of generated waste. In this university, it is expected that at 400 level, you would have acquired some knowledge of food science techniques, such as food processing skills, while in 300 level, and should be able to operate some food processing units and equipment effectively. So this course involves both the practical session and the theory. You agree with me that it's not enough to just, to be taken through the theory of any course and not being exposed to the practical. So objectives of this course is actually to enhance your capacity as a learner in food processing and preservation, especially as it relates to milk, with specific emphasis on milk and milk products. So I hope you are ready to learn and put to practice what you will be taught, because the key to milk processing and production of milk products will be placed into your hands, and you're expected to put in your best as the time to do your work is placed at your disposal. Thank you. Let's move on even to the course outline. You have the first module, which is going to be in about 2 sessions, which is milk overview. The second one is fluid whole milk, otherwise known as pasteurized homogenized milk. Then the evaporated milk, sweetened condensed milk. You also have dry milk powder, ice cream. In Module 7, you'll be taken through lollies. Hope you can remember. While very young, it's usually put inside a stick, very near to ice cream. Butter. Many people used to mix up butter with margarine. Butter is actually made from milk, the cream of milk, while margarine is made from vegetable fat. We also have fermented milk products, most especially the common one we're going to deal with yogurt as well as cheese. The cheese that is so common this side of the world is the soft cheese, usually referred to in Yoruba as warankashi. In continuation of course outline, you also deal with dairy waste management and processing. There's no use wasting resources. Values can be added to some dairy waste, such as whey, uh, whey, dairy whey can be had. You can add value to it. You can also extract some protein that can be added to improve the nutritional content of other food products. We also have dairy plant sanitation. It is very important to keep the dairy plants neat and clean to prevent microbial contamination of equipment as well as the products in the place. Module 1. Today we shall be starting with Module 1, Session 1, and the main focus is going to be milk overview. Session 1 outline includes learning outcome, introduction, milk and its components, milk chemistry, and milk microbiology. Objectives. At the end of this session, students, you as a learner, should be able to define milk, should be able to mention some of the components of milk, should also be able to describe the significance of processing raw milk into milk products. You can see a picture showing up inside with a liquid white, usually referred to as milk, making a splash in a cup. So the question is, what exactly is milk? Milk is the lactose secretion from the mammary gland of mammals. And in various settings, because of the variation of milk components, the variability, and the importance of milk in the milk industry, there are legal definitions available also for milk in order to set a legal standard for milk. So therefore, in other claims, milk is defined as lactose secretion practically free of cholesterol obtained from one or more healthy mammal, usually cow, which contains nothing less than 1.5% of milk solid and 1.25% of milk fat. Now, there are several sources of milk. One can be cow. You can also get milk from goats. We can also get milk from mare, that is the female horse. Milk can also be obtained from llama. This is a variant of camel. And of course, you agree with me that we can also get milk from humans. However, the milk for human has not yet reached full commercial level, although in developed countries, you can now store human milk and make it available for mothers who, for one reason or the other, could not breastfeed their children. So you can see that you can get milk mainly from mammals that has mammary gland that can give suck to their young ones. Milk is the essential first food of the young, and it is a complete meal. It contains all the nutrients that is named with food. So, and that makes it very complete. You can see that a young mammal can survive even up to 6 months feeding on milk alone from the mother. And it has high biological value of about 0.75 to 0.8, talking about the quality of the protein being very high. And because it's a complete meal with high protein quality, it is also very susceptible, highly susceptible to microbial contamination. Milk can be described in several ways, one of which is that it is an oil in water emulsion, whereby fat droplets are dispersed in liquid water that is to form emulsion, whereby the water is the dispersing phase and the fat droplet is the dispersed phase. Can also be described as a colloidal suspension. You agree with me? It's very obvious that milk is not a clear liquid. There's some nutrients, some materials that are suspended in the dispersing phase in the water, and because they are suspended, it will give it a colloidal appearance. So we can also describe milk as a solution, whereby some nutrients are soluble in milk, in the water phase. Example of such material, soft substance that is soluble in milk, is the milk sugar, usually referred to as lactose. Principal components of milk varies. Principal components of milk varies, but the most abundant components of milk is water. The principal component of milk varies from animal to animal, and even from uh, animals of the same species. And that is why when we are processing milk in food, we usually have a blend of milk from various animals. I mean, various animals, even though they may be of the same species. So if you have cow A, the components will vary with respect to water, solid, not fat, fat in dry matter, carbohydrates, protein, ash or mineral substances, organic acids, vitamins, and miscellaneous. And that's why we have to blend them together. Usually the range for water is as stated above, up to about 85 to over 88%. It should also be noted that there's so many other things in apart from nutrients, food nutrients that are in milk. We have antibodies. Antibodies are in milk, immunoglobulins. There are also enzymes that are present in milk. The different terms are conversant when we are dealing with milk, and it is important to describe the milk fractions. The first one to be described is plasma, which is the milk minus the fat to give skim milk. This is usually milk that contains very low uh, amounts of fat. Not that there won't be fat there, but the fat will not be as significant as it is in whole milk. Next to it is serum, which is plasma minus casein micelles. Casein micelles are a type of milk protein which is different from whey protein. So once the plasma, that is the milk that is void of fat, is subjected to some other process to remove the casein cell, we are left with serum. Serum can also be referred to as whey, liquid whey. We have the solids, not fat. Apparently, there are some solids that are fat, there are some that are not fat. So if it is not fat, if it's solids not fat, we'll refer to them as SNF, which includes proteins, lactose, minerals, acids, enzymes, and vitamins. And we also have total milk solids, which is a combination of the fat and the non-fat solids. It is important to note these definitions as we move on in this course. Colostrum. This is the milk produced in the first 2 to 10 days postpartum. In some climes, it is referred to milk produced in the first 2 to even 15 days postpartum. Colostrum is it is very pertinent to talk about colostrum because it contains antibodies, it contains all that is necessary to build immunity in the young mammal, if it's cow, in the young calf. So therefore, before it is advisable that before collecting milk from a new mother, it is allowed to feed the calf for the first 10 to 15 days so that the young calf can actually receive nutrients and substances that will help build its immunity in the new environment. So this is very important because the young calf, is in a new environment which is not sterile and may be exposed to sicknesses and diseases, which is important for it to fight against. So it's able to stand against diseases and anything that can challenge its normal growth. Colostrum is different from the milk that is usually obtained generally as commercial milk. It has very strong odor. It's bitter in taste. Also, in terms of color, it is reddish to yellow in color, and this may be as a result of high vitamin A content. It also has large percentage of immunoglobulin antibodies. It is richer in other milk constituents except that in lactose, potassium, pantothenic acid, vitamins, and water. And because it is not rich in water, it is more viscous than the commercial and the milk obtained for commercial purposes. Milk structure. Can see on the right side different um, different structure of milk. We have the A region, B region, and C region. All of these are under different magnification of microscope. Milk structure is made up of milk plasma, casein micelle, milk serum. It also contains lipoprotein particles and cells. Now, the A region is ×5 magnification of microscope, and it is just the milk that is opaque, that one cannot really see what is inside, obviously. And then we have the region B is ×500, thereby we're able to see the plasma, which has been previously defined. We also have fat globules, which are dispersed in water. And then the region C has ×50,000 times of magnification. And there we can see a lot of other things that makes up the structure of milk. Serum is obvious, casein micelle are obvious. We have the membrane, and we also have fat globules. All of them very obvious, and it is important to understand the structure of milk, especially in milk processing. Milk chemistry. Milk chemistry include milk lipids. And other milk lipids we have are mainly triglycerides. It's a glycerol backbone binding up to 3 different acids. Also have the fatty acids, which are made up of hydrocarbon chain and a carboxyl group. Other milk lipids include phospholipids, cholesterol, free fatty acids, and diglycerides. Also, under milk chemistry, you will talk about milk protein. About 95% of the nitrogen in milk is associated with protein, and these are casein, Casein is about 75% equivalent to 80% of milk protein. Serum or whey protein, as earlier mentioned, is 18%. And then we have enzymes, which are mainly hydrolysis, and miscellaneous proteins that makes up about 2%. Hydrolysis in milk include lipoprotein, plasmin, alkaline phosphatase. Alkaline phosphatase is a very important enzyme because it helps to check the adequacy of milk pasteurization, which is a very important parameter in milk processing. Milk carbohydrates, still under milk chemistry. We have lactose, made up of glucose and galactose. Then on its own, we have glucose and also galactose on its own, and oligosaccharides. All these make up milk carbohydrates. Milk microbiology. Ordinarily, milk is sterile at secretion as it is coming from the animal. But by the time it gets to the udder, there could be contamination, and also depending on maybe the treatment the animal has gone through or is going through. So it is expected that to have sterile milk collected at the udder, that the animal be kept healthy and the surrounding environment also kept healthy. The handling equipment, the milking machines, the handlers, the environment, and even the animal itself. It's important that the animal be kept clean and healthy. Sanitizing liquids can also be applied prior to milking, and the environment kept clean. But although it is sterile, it is highly susceptible to microbial contamination and can be contaminated by bacterial coliforms and molds. Can also be contaminated even by the hair from the animals. Those are physical contaminations. The environments, if there are dust and dirt, grasses around, those are issues that need adequate attention. In summary, milk is a complete food, and the major composition of milk is water. Milk is an emulsion, and unless contaminated, it is sterile. Yes, raw milk, unless rapidly processed, spoils quickly because milk is a complete meal and encourages the growth of microorganisms. However, milk processing may lead to some losses from your previous knowledge in year 3. So it can lead to loss of nutrients, it can lead to loss of quality. So all this needs to be noted. We'll be able to know is it the significance of processing raw milk as opposed to consuming just raw milk on its own. For further reading, you can consult the following text: Dairy Technology, Principles of Milk Properties and Processes. Can also consult Processing Technologies for Milk and Milk Products, Methods, Applications, and Energy Usage. And for links to internet-based reading, we have the Dairy Science and Technology ebook. All of this will be placed on the virtual library for your attention. Part of the work to be done today is that there will be the distribution of the class into 2 groups for a debate. So we have Group A will defend consumption of raw milk, and Group B will defend consumption of processed milk. You prepare against the next class. Then we have the discussion forum, which is opened at the university's learning management system. And the question is that if given the opportunity to choose between raw milk and processed milk. Which one would you prefer to consume? And give reasons. Yeah, I want to thank you very much for the opportunity to start this class with you, and I hope we have a wonderful time ahead. Next class, we shall be talking about grading of milk, testing of milk. What are the various tests that can be used even to check milk quality, and not just milk quality, milk safety, the safety of the milk and milk products to be consumed. Once again, thank you for listening and hope to see you again next class, same time next week. Thank you and have a nice day. God bless.